we end up using our two-sample t-procedures when we do not know the standard deviation. And in this case, this is obviously more common. And we have both our confidence interval and our hypothesis test. So for our confidence interval, once again, these equations are on your formula sheet. We have estimate plus or minus the margin of error. And so our estimate is the difference in sample means. And when we do not know standard deviation, our critical value is going to be our t, and then our standard error is used instead of standard deviation. So S1 squared over N1 plus S2 squared over N2. So critical value and standard error. Okay. For the hypothesis test, we are looking at test statistics is now going to be the statistic minus the parameter divided by the standard deviation of the statistic. So we'll be using the standard error, of course. And so we get t equals x1 bar minus x2 bar minus mu1 minus mu2. And please note here, mu1 minus mu2 will be equal to 0 if we are assuming no difference. Okay? And then that is going to be over S1 squared N1 over, sorry, the square root of S1 squared over N1 plus S2 squared over N2. So it's very similar ideas to what we saw in 10.1 with the proportions. One thing we do need to note here is, I'm just going to get this line erased here. We'll just pop it in a little shorter. The degrees of freedom is the smaller, for both of these, the smaller of N1 minus 1 or N2 minus 2, minus 1. Okay, and that is so that we use more conservative results and reduce our chances for our hypothesis testing of T1 errors. Your calculators actually use a complicated formula, which we won't get into, to provide a more accurate result for the degrees of freedom. So what we're going to do right now is just have a quick look at, so you should know right now how to find your critical values. And the format here is pretty much the same. On your calculator, however, you can go into stats, tests, and here you've got your options of the two sample z-test. Now that's, again, not likely to be used because we usually don't know our standard deviations, or the two sample t-test, or you can go down to your 2-sample t interval. So I'll have a quick look at that, and this should make a lot of sense. So you can either enter stats and enter your sample means, x1 bar, and your standard deviation for the sample, and your n1, and the same for x2, S2 and N2, and enter your confidence level. Now, pooled, here this would be if the standard deviation was the same. In most cases, we would just say no. So you can leave that as no and then do your calculate. If you don't have the stats and you've got the data, now you're entering in which list you have chosen. Frequency can stay as 1. You can enter your C level, confidence level that you want, and once again choose no for pooled. Okay, let's go in again. If we're doing the 2-sample t-test, similar things. For data, once again, you enter your lists and you state which type of hypothesis testing you're doing. Once again, unless you've got the same standard deviation, we're doing no to pooled, and then you can calculate or draw. And then, of course, it's similar for the stats. Now, this example here is to be done for homework before class. You shouldn't have any difficulties with it. You've got formulas, procedures, pretty much the same. You're going to do state, plan, do, and conclude. You are going to answer, does the data give good evidence that on average nursing mothers lose more bone mineral? Carry out a test and report your conclusions. And B, construct and interpret a 95% confidence interval. So you will be entering breastfeeding women into L1 and other women into L2 and doing your 2-sample t-test for A and your 2-sample confidence interval for B. And so make sure you've got that done on a separate piece of paper for class. Thanks.